Hello, the Data Science and Machine Learning Special Interest Group from the Geophysical Society of Houston welcomes you and invites you to listen in to the recording of the 2020 Entrepreneur and Thought Leader panel, titled A Sustainable Digital Future for Our Industry. This event was hosted live Wednesday, July 22nd at 10 a.m. Central Daylight Time. A very quick thank you to our sponsor, Quantico Energy Solutions, who thanks to their donation made this event free to all attendees. A reminder to all listeners that events such as these are hosted all the time by the Geophysical Society of Houston and may be registered for through the GSH's website. That website is gshtx.org. Now you may be asking yourself why we decided to host an event such as this, an Entrepreneur and Thought Leader panel, at this particular time. Well, at the Data Science and Machine Learning Special Interest Group, we believe that for our industry to survive and endure, we need to create a culture where discussions about the importance of adopting new technologies take center stage. More importantly, we need to bring together the entrepreneurs and thought leaders that are helping bring about this change and listen to their experience and learn from them so that we can grow as an industry and thrive into the future. So as you sit back and listen to the discussions throughout this event, you'll see key themes pop up that revolve around some key technologies that have grown to immense heights in the past couple of years, such as data science, machine learning, software as a service, satellite imagery, cloud compute, and cloud storage. Now, you'll also see that these 6 individuals have very diverse backgrounds, which is 100% intentional on our behalf. We brought together people from academia, from tech companies, and from E&P upstream technology companies so that they can give you an idea of the amazing technology that is being developed right now in our industry, and that we have the knowledge, we have the skills and the talent to overcome the current obstacles and not only survive today, but thrive into the future.
Thank you everyone for attending. I'm a huge fan of what this interest group is doing, and I'm really honored to be amongst an all-star panel with, I think we have 10 plus patents and 4 or 5 PhDs on the panel. So it's really, truly great to be here. All right, so first off, I want to talk about what AWS is doing to guide and encourage digitalization efforts. This is actually not a question that I came with. This is something you will see all the speakers talk about, these preloaded questions. But one thing that AWS is doing and that I want to talk about is growing the subsurface data universe. Now, AWS created the first subsurface data lake with Shell all the way back in 2018, so not that long ago. And from that, that has since turned into the Open Subsurface Data Universe, or OSDU, in March 2019. And the idea behind this is that you can have a standardized way to curate and scale your data. From the technology perspective, it means that you can take advantage of AWS solutions like Glacier Deep Archive Storage. If you've never heard of this, it's cloud-based storage that's cheaper than tape, or some of the HPC or high-performance computing innovations. But ideally, digitization to me comes right down to the data, and that's kind of where AWS and our partner network fits in. Now, I say partner network. If you're not familiar, what I'm talking about is the APN, or Amazon Partner Network. One thing that I've heard time and time again from the community of oil and gas companies and energy companies we're working with is that they want to be able to leverage really cool advances in technology, things that startups like Quantico are doing, so that they're able to use those at scale. And that's exactly where the partner network comes in, where we help these technology partners build and launch cloud-based solutions. Next question I'm going to talk about is, what is my take on the impact of machine learning and data science to the industry? So quick disclaimer, I'm a geologist by background, like master's, PhD geology. I worked my way up through interpreting seismic and working as an ops geologist. And when it comes to data science, it's actually in the core of what so many people do. reservoir engineers, geologists, we've been using data science in one form or another in terms of a data-driven solution. Yeah, the tools may have changed. It used to be things like Excel and lots of analytics dashboards, and that's given way to Python and Jupyter notebooks. But at the foundation, the subsurface domain has this in our DNA. Now, looking at how to take that to the next level, I like to actually use companies like Amazon at scale. I don't want to know just what oil and gas companies are doing. I want to know what the best technology companies are doing. So when you make a purchase from Amazon.com and you see recommendations for other books or things you might like, that's ML-based applications right there. If you use Amazon Prime to get fulfillment center optimized routes so that you can get your stuff in 1 to 2 days, or use Alexa integration, that's ML right there. And so using those types of broad, actual, tactical what ifs and creating workflows from there, I think is what the energy needs to ultimately be competitive, an environment that's marked by uncertainty. Being able to drive production, decrease your price per barrel, and adapt to this new normal is where data science and machine learning is going to take over. I think I have 90 seconds left. The last thing I want to talk about are key challenges in bringing change to the energy industry. First off, I have spent too much of my life searching for data. I guarantee most of you have too. Data in the energy industry is siloed by design. In order to evolve and make good changes so that you can do your reservoir engineering faster or your geophysical interpretation faster, we tend to build up and evolve these data silos. I like to view them as like a sea of stalagmites kind of reaching up that make really good progress, but make for cross-data solutions to be really challenging. For users, this is poor data integration. It's an inability to easily share data with JV and service partners, and it's really hard to get value. So to me, that's exactly what the key challenge is. I'm happy to talk about ways that we can visualize data lakes with schema on read, ways we can have a single data repository with metadata indexing, but data and getting that together is job zero. It is foundational to everything else downstream.
Excellent. Perfect. Right on time, Liz. So next, I believe we have on the list, I think right up next, I think is Josh from SourceWater. Josh, are you ready to go? I see that you turned off your video and there you go. It's like,
sure.
oh no,
I want to distract from Liz.
No problem. So Josh,
hi everybody. Yeah.
If you I know you have a couple slides. Just let me know when to go to the next one. Okay.
Oh, really? Okay. Because I'm going to go through a bunch of them really fast.
Okay. Yeah. Okay. Then just let me know, I guess, and we'll just jump through them. Keep the visuals up to date. So this is where you start, right?
Sure. Hi everybody. I'm Josh Adler. I started SourceWater as a spinout from MIT Energy Ventures about 6-7 years ago. And we started as an online marketplace for water in the oil and gas industry, basically sourcing and disposing of water and optimizing those logistics, because water management is actually the majority cost of oil production for onshore unconventional wells. But what we've turned into is a data science-based analytics and visualization platform for the oil and gas industry, not just for water, but for everything going on the ground. And if you go to the next slide, where this evolved from is that we were trying some years ago to find all of the frack water pits that supply all of the hydraulic fractures that happen in the Permian Basin, because we found that anybody who had a frack water pit on their property seemed to really love the idea of being able to market their water on an online marketplace. And we discovered that there are no regulatory records of surface water or water pits used in hydraulic fracturing in Texas. Basically, if you are a surface owner in the state of Texas, it's your right as a Texan to dig a ditch on your property, fill it with your groundwater, and sell it to an oil company. And there are no permits that you need to file to do that. So we were trying to figure out, how do we find all these people who have surface water on their property that's literally just getting wasted, blowing away in the sun, who want to market it? And what we realized is we can see those people, their water pits from space, and then associated with regulatory data. And so we started building, you can go to the next slide. And so we started building systems for identifying surface water, specifically frac water pits and reserve pits, and distinguishing that from all the other kinds of water features that are out there. And then we realized, as we compared the kind of activity we were seeing with these water pits, that we were really able to predict hydraulic fracturing activity. It turned out 6 to 9 to 12 months before other regulatory-based data services could do that, because they were waiting for the operator to file the report late to the RC to get to Frac Focus, and Frac Focus to process it and release it. And what we realized is this water data was lagging by 6 to 12 months from reality on the ground, but we were actually seeing what was happening within a couple of days of it happening, because we were looking at 3 to 5 day satellite imagery. So if you go to the next slide, what we started using was analyzing Sentinel data from the European Space Agency and building all kinds of automation and machine learning on that. You can go to the next slide. And some information about it. But basically, they cover the entire Earth every 5 days. And so we were able to cover the entire Permian Basin every 5 days. Next slide. The challenge with that is, if you were covering the whole Permian Basin, and we've done this calculation, and you were having humans search the entire, some close to 100,000 square mile Permian every 5 days on that cadence to be able to identify every new feature that occurs there, you would need a team of about 150 people working 3 shifts a day, 8 hours, in order to cover the entire Permian Basin imagery based on the real times that we found using offshore teams with real timing. So the only way to do this was through applications of artificial intelligence, machine learning, and computer vision. If you go to the next slide. We also realized that getting beyond water, we realized actually there's a lot of things we can see happening on the ground in the satellite imagery that either never show up in regulatory data like water pits, or that only show up with a 6 to 12 month lag, like say initial production, some of the water injection data, completion reports, other things. And so we started to broaden what we were building to analyze the surface with. And the next step was really to identify well pad construction. You can go to the next slide. Yeah, can you push play on the, for the video on the bottom? So if you look at this image that we pulled out, you're seeing with our imagery how a series of well pads and frac ponds are getting constructed over time right here. These well pads tend to predict new drilling activity 2 to 3 months earlier than drilling permits predict that activity. So what we're able to see is who's going to be drilling where based on the start of oil field construction on the ground several months earlier than the regulatory data that comes out of your conventional kind of regulatory scraping services and the Railroad Commission. And so if you go to the next slide, we started building deep learning systems to distinguish what these things are, and breaking it down using convolutional neural nets. And then next slide, we were able to pick up all of these well pads as they happen on the ground, as well as things like completion crews, new roads, and frac pits. And so far, we've had 7 US patents granted on uses of machine learning, AI, and computer vision to identify energy infrastructure. And so that turned into DirtWork Alert, which is a product we just launched. The other benefit of this, you can go to the next slide, is that because the imagery is much more current, pretty much the whole industry today just looks at Google Earth. But in the further reaches of the Permian Basin, what you find is that the Google Earth satellite imagery, although it is high resolution, tends to be 2, 3, or even 4 years old, which tells you nothing about what's happening on the ground in reality. And so, for example, in this exact spot, if you go to the next slide, on Google Earth, you can see that there's nothing there. But if you look at imagery that we're analyzing from a couple of days ago, there's 4 frac water pits, a well pad, a reserve pit, a bunch of other things. So the currency of the data is very important to keep up competitively. And then next few slides, we can kind of zip through. So basically, we translate all this into SaaS platform that combines it, contextualizes it with all the other regulatory data on the surface and in the subsurface to place all the frac pits, all the reserve pits. Next slide. All the new dirt work, associating the dirt work with the operator. So for example, in this case, we're looking at all kinds of regulatory data to create context and probabilistically have a confidence level about who's building what where. And so if you go to the next slide, you're able to zoom in on the locations and the pads. So for example, where is EOG preparing to drill, but has not yet filed any drilling permits? And you can actually specifically pull that out. You can look specifically for which operators are starting construction in locations where there is not a drilling permit yet. Next slide. And so the end result of that, you can go to the next one too. The end result of that is that here you see these red dots are well pads that we detected in the satellite imagery. And then over about an 18-month period here, you see where the red dots convert into green dots. The green dots are the drilling permit. And what you find here is that although there's quite a bit of variation, the average spread in this part of Reeves County, which is really the heart of the Delaware Basin, there's basically about a 6-month average lag time between when well pads get built and when the drilling permits came out. So it's a pretty significant predictive lead. And we're continuing to study that and analyze the real relationships between what's happening on the ground. Because one of the interesting things here is not only had no one ever used AI machine learning on satellite imagery to understand what's happening on the ground in the upstream industry, but actually nobody seems to have ever studied the actual relationships between the regulatory data and what's happening on the ground. For example, the time and predictivity and probabilities linking drilling permits and spuds, for example, because there was no alternative. So why even study it? And what we've found in studying it is that drilling permits turn out to not be nearly as good of a predictor of new drilling as you might assume. They're often late. Sometimes the drilling permits come out after the well was already drilled, or they're missing, they're not linked. So that's part of what we're trying to understand are the differentials between the regulatory data and data gathered from other sources like the machine learning and computer vision analytics on the satellite imagery. And that's my presentation for today. Thank you very much.
Thank you so much, Josh. That was really interesting. I completely agree. I think this is the only application I've seen so far of machine learning and AI on satellite imagery for our industry, at least the upstream sector, right? So that's very cool. Thank you so much for sharing. All right, so next up is Claudia. So Claudia is having some maintenance work. Are we okay, Claudia?
Yeah, I'm still okay. They haven't arrived yet.
Excellent, excellent. So I'll let you get started, Claudia.
Thanks, Eduardo. So Eduardo already introduced myself. So let me make one disclaimer. I'm a mathematician by training. I have not worked in the oil and gas industry or in any research related to oil and gas. My background is more on the biology side, ecology and biomedical applications. But I'm the director of the HP Data Science Institute, and so I'd like to introduce that one first. Can you go to the next slide, please? So this is Hewlett Packard Enterprise Data Science Institute. So this is our main website. Go to the next slide, please. We've been around since 2017 in this instantiation. There have been other core facilities dealing with high performance computing around before that. So UH has a pretty long history of having these types of institutes. We do run a core facility. In the picture you see one of the machines we have. That's one of the main things we do. So we provide high performance computing capacity to our research community on campus. And then the other three are sort of our core functions. We participate and facilitate research. So we run seminars, like the interactions with Geophysical Society is one of the things we do. We have consultants that our researchers can tap into. And then we sponsor undergraduate research. So that's an opportunity actually also for industry to interact with us on the research side. So I hire undergraduates who then get plugged into research collaborations between our faculty and industry. So anybody who's interested is feel free to contact me. We do quite a bit on the education side. We have a certificate in high performance computing. We offer a lot of short courses. We're also currently working on micro-credentials. That's something I'm going to talk more about in the next slide. And then we have partnerships with the public and private sector. HPE is obviously one big partnership. They gave us a very large donation that enables us to actually do all this work. And we have K through 12 programs now. Next slide, please. So we all got these questions, so I'm just going to walk through the 3 questions that we got. So what are we doing with encouraging digitalization efforts? And I want to focus primarily in the educational offerings because that may be of interest to many of you in the audience as well. So as I mentioned, we have a lot of short courses, programming, machine learning. These are open to the outside. A lot of the participants are our students, obviously, but we are open to do this on the outside as well. We're currently working on micro-credentials. UH Energy, which is a different unit, is starting to offer micro-credentials in energy data analytics. So this is the Energy Institute or UH Energy. So if you're interested in that one, that program is about to start. That's about upstream data processing and upstream data models. It's really meant for industry professionals, and it's just starting. We also planning on a workshop, on a Python workshop for petroleum engineering. That's a student group here. They ask us to develop something like this, and this is the type of stuff we do. So if we get a request from a group, they want us to do a workshop internally, we are ready to set up. Externally, we will work with whoever wants it to tailor it to them. Next slide, please. So I'm less going to actually talk about specifics about machine learning and data science. I think this would be really talking to the choir here probably. But what I would like to emphasize here is this is an example of a collaboration between industries, so Shell and the University of Houston. And this is the type of stuff where we as an academic institution can really help advance applications through research in industry. Just one example is what enables us to do with all this data and including the technology in there is sort of real-time assessment of what's coming out. And this is one of the examples. University of Houston was involved in a research project. And so I think this is an opportunity machine learning and data science in general offers, that we have a lot of expertise also on a more theoretical side. So we can do the research to advance the current methods that we have and help industry to implement that into their current workflow. And so this is sort of the real-time assessment of data, I think, is one of the advantages that we have with the technology we have and the tools we now have. So next slide, please. So key challenges, and this is really a perspective, this is the academic perspective of key challenges. So this is not a very technical one, but I'm sure everybody is struggling with this. It's workforce and culture. So this is a very fast developing field. And so keeping up with new developments and upskilling the current workforce is obviously a big challenge. And we at University of Houston are ready to help industry with this. On the workforce developing side, University of Houston, we have over 1,000 undergraduates in computer science, for instance. Computer science has been going through these boom and bust cycles, and there's an upward trend of the number of graduates across the country. So that the table you see, that's US data, not the University of Houston data. We're included somewhere in that data, obviously. But I think what's really important is also not just to train people who have the data science expertise, but also have the subject matter expertise. I think at the intersection of the two is where real advances can be made. And lastly, and this is what I'm going to end with, is their cultural issues. It's a transition, it's a change in the field. Change is always difficult for everybody. And so bringing a company or a whole industry sector to using new methods that are perhaps not as tested as the old methods, and convincing people that there are new things that you can do, that's a culture issue. So that's something where you really have to work with people, making them understand what these new methods can do. And with this, I'm going to end. Thanks.
Thank you so much, Claudia. That was very interesting. As you guys can see, there's a lot of collaboration going on between the Data Science Institute and industry. And there's obviously opportunities there for our companies in our industry and the upstream sector and downstream sector to take advantage of all these resources and partner with the university to upskill our workforce. So I think you really hit hit on that point there. I think it's very important, Claudia. So without further ado, let's, Arvind, do you want to get started?
Yeah, thanks for the invitation. And as you said that, like already introduced me, that I'm VP of Data Analytics at TGS. And broadly speaking, my group actually looks into all the software development, data management, cloud orchestration infrastructure, high performance computing, and analytics. And it was not serendipity. It was by design that for truly accelerate digital transformation, all these groups need to work together very well. And so when we were like 3 years back, when we were actually embarking on this journey, we decided to bring this group together and to create a like center of excellence in our company, and which has paid really well during COVID times, because our group was doing a lot of remote working and using technology a lot. And by February, when everyone realized that, okay, everyone has to work remotely, and since we had actually internal expertise, we were able to quickly accelerate. We have all the tools, we have all the infrastructure to do it. And so having a center of excellence in your organization actually helps as a nucleus point for digital transformation. But most of my career has been with BP, where I worked with like all the way from research to drilling wells. And I have seen kind of firsthand how E&P decisions are made. So if we go to next slide. Yeah. So like it's right now, it's a quite sequential process, and everyone has actually said something about it, like data discovery. It's actually quite onerous process. And then once you think that what data you need, then you go and convert into information. Like basically it's a pyramid that you are condensing that information into higher and higher value things. And by the time decision is like the time to take decision, we are kind of compressed timeline, that we have already exhausted all the time in actually discovering data, converting into information, converting into knowledge, understanding, and that yields suboptimal decision making. And so this is kind of today. And what we truly want is, if you click, is this, is a kind of integrated process. So you're expanding the decision making cycle, and you are actually now feedback loop, that by the time I have actually come to a decision point, I actually needed more data. Then only I realized that I need actually a little bit more data. So it needs to be a full circle of integration, and it can't be sequential. And it can only happen if you have almost on-demand tools. The data information, like data conversion to knowledge and understanding, is actually a not sequential process, but almost on-demand process. So liberating the decision maker from all this work. Is it easy? Are we there? No. But if we are there, it will actually help us make cheaper, faster, and better decisions. So, and machine learning and broader digitization has a lot to do to help us achieve this goal. Next. So when we talk about AI and human, or machine learning, I'm going to use AI and machine learning interchangeably. So for all the practitioners, it will grate on them, but it's a colloquial term. So that if you have a lot of training data or you have less training data, and the problem is either low or very low dimensional problem or high dimensional problems. So if I have a lot of data, actually most of the problems have either has got good solution or already on the way to create solution. However, our E&P and especially subsurface problems are actually quite challenging, because we don't have very high quality training data, and the complexity is very high too. There's a lot of subspace missing. And so the space on this that we are working on for subsurface is, next slide, next, is here that, and we have like some of the, TGS has made some advancement in solving some of these problems, but as a broader industry, we are in that oval circle. And we have to kind of move that blue line, which is where ML and AI has been quite effective, to the red, where it's actually very difficult to do. Like just example that if I'm doing an online sale, and if I miss that the person who bought this T-shirt, the predictive analysis, the person who bought this T-shirt also buy that wristwatch or whatever. If I miss, it's not actually life and death situation. However, if I miss the poor pressure prediction, there can be a blowout. So it's actually, when for a subsurface, it's actually not that trivial, and the accuracy is very high. Needed is very high. So, but the broader advancement which is happening, we are incorporating it, and we are actually converting it into products which can actually help move the needle. Next. Next. I already. So this is kind of a chart that in my group, in AI group, we talked a lot about it, because we get actually squeezed from both sides. Is that let me describe the plot. Is the bottom is effort, that how much effort is needed, and the vertical is result and accuracy, how quickly you can get the, like how accurate the results are. So because all these machine learning tools are broadly available, and with basic understanding, we can actually go download it, and actually with some data set, we can actually get some result. We do get result very quickly on sample or trial data set, which kind of, and we start over promising and generate hype, which reduces some of the credibility for us in the industry. And on the other hand side is the old guard. If I be blunt to say, the old guard is like, unless you have solved all the problems to 99% accuracy, it's not useful. So you have hype and prejudice, and the machine learning practitioners are squeezed from both sides, that they have to actually justify that, no, this is actually not hype, but also defend that just because I can't solve all the problem doesn't mean that it's useless. So, and I think the best way, like the guidance, what we are practicing is to make impact is by showing quality results. Just like the first presentation, that has a real life result using machine learning. And that's how we are going to move the dial. This might show that I'm a pessimist, but no, I'm actually quite optimist. Can we go to next one? Because we are living in actually very good time. It is the right time because of convergence of technology and demand. If we started this project 5 years earlier, we would not have some of the things that we had at our disposal to solve these problems. If we would have started like 5 years later, someone else would have solved this already. So like some of the things that will need it, flexible compute, AWS, GCP, and other people are actually providing very high quality flexible compute. Machine learning, PyTorch and TensorFlow, and you name it, like a lot of development. The whole world is working on that space, and we can piggyback on those developments. Demand clients, because of all these like cost constraint, the clients are actually asking for faster turnaround. So efficiency itself will be needed for this transition. Someone actually referred that visualization, like I do not underestimate visualization. It's actually considered as an afterthought, but if we are going to make it as machine learning and broader digitization as the key tool for digital transformation, then visualization needs to be intuitive and like ubiquitous. And geoscience workflows has been improving, and data literacy and data standardization, data curation is actually happening. We have TGS also has built a data lake and all the tools necessary to accelerate the data consumption into higher value things. So at the end, like I'm actually quite optimist and excited about the future of ML and broader digitization in our industry, because we are at the right time. So with that, I'll leave it to the other guys.
Thank you, Arvind. That was very interesting. I'd actually, we talk about this, I'll go back to it very quickly. This pyramid that you showed here, I'd never seen it represented this way, but it's a striking image. It is a very valuable visual to understand what the key challenges, one of the biggest key challenges is, and like where we need to be. So that was very cool. Thank you. So Brendan, you can go ahead and start if you're ready.
Great. Thanks, Eduardo. Thanks, everyone, for being here today. So I just have one slide. I wasn't sure how many we're supposed to have, so we'll kind of pack it all in here. Yeah, so I'm sure some of you have heard of Enthought, and some of you probably have heard of us and maybe don't know what we do, but we are a scientific computing company founded actually way back in 2001. So our CEO, Eric Jones, had finished grad school and decided to take some of the codes that he'd written in Python to solve problems he faced in his PhD research, along with some other colleagues, and formed a library called SciPy. And they open sourced it, and many of us working with Python today will be familiar with that. We use it a lot, and it's certainly become kind of a bedrock of computational science, and Python now. So he built started Enthought to use this library and build scientific software to solve business problems. So we started by actually providing a Python distribution that was more easy to install by enterprises, because way back then it was actually really difficult to get done at the time. We were teaching training programs in scientific computing in Python. And then over the years, we went from kind of being the crazy people talking about this weird computing language to seeing Python start to crop up more and more. Universities started to pick it up as their initial training languages. And it was becoming more and more popular for scientific computing. And then when machine learning and data science really started to come into its own, some of the big companies picked Python as the language they developed their machine learning frameworks in, which sent Python to the stratosphere in terms of becoming one of the dominant languages in machine learning today. I don't want to court too much controversy there, but yeah, so Enthought's really been driving that forward. We're the primary hosts of the SciPy conference that actually just took place last week, the week before, all virtual this year due to the virus things that's going on. But all that content is typically available online, and certainly machine learning, has been playing a big role in that in recent years. So what Enthought's focused on now is, over the years of kind of building these software solutions, we've noticed some patterns emerge about how these technologies get adopted successfully by companies. And so, now we kind of say our mission statement is providing technology-enabled solutions. Using scientific software that deliver applied digital innovation to transform science-based businesses. And this has evolved over time, but when we say applied digital innovation, what we're talking about is analyzing business processes and workflows, understanding what actually drives the value in the business decisions that you're trying to transform, per se, and determining where we can use these machine learning and scientific software modeling and simulation techniques to take out the tedious work, the mundane work, the grunt work that the scientists typically need to go through before they make their high-level decisions. We don't jump right to, how can AI, interpret a seismic volume, per se, but we actually get into that workflow, look at all of the mechanics that's involved in that, the mouse clicks, the data transfer, the stuff that takes up a lot of time in these analysis, and start to pick off those instead of kind of promising magic. And that's, we'll come back to this as part of this discussions, but that's partially what we do. Anyways, that's a picture of me pre-COVID. If you see me around, I'll probably look like that moving forward. But I have a background in computational science, and I worked in some research and development teams as part of large oil and gas companies early in my career. And that's when I really realized the possibility of combining those to solve problems, for example, in geoscience. Back in 2016, I wrote a tutorial article in the Leading Edge, just kind of taking an old problem on facies classification and showing how that can be done with scikit-learn. And we launched a contest based on that, and had a lot of interest. And that's when I realized that there's really something here. A lot of subsurface professionals, geoscientists in particular, are really interested in using that, and we really dug in. Much of the conversation for that contest took place on the Slack channel, the Software Underground, which is kind of a community online of subsurface professionals who like to write code and use computers to solve problems. And so the Slack channel is a really good resource for ideas around solving problems across the subsurface. And you're free to check that out. That's just an open society. It's completely free to join. And we do hackathons, and we recently had an online conference some of you may have heard of called Transform 2020. And all of that content's available online. We have tutorials and a week-long hackathon and sessions from across the board for some interesting things that happen. The right-hand side of the screen there, I just have a couple examples of technologies that we've been building recently. So we're building tools that help streamline a few geoscience workflows. On top, that's a machine learning enabled seismic interpretation. So breaking out the packages there. And that analysis is based just on the classification of, I think, 4 or 5 inlines. So we're able to get that. And we're focused on visualization as well. And so it's a visualization of the result on the left, but then also kind of a confusion view on the right-hand side. The bottom is a thin section application that we're building to annotate and classify thin section images. Yeah, I think I'm running out of time, but if you have any more questions and want to follow up, there's links on there to get in touch.
Awesome. Thank you so much, Brendan. That was really interesting. I actually didn't know your founder was pretty much the guy who came up with SciPy. So that's really cool, man.
One of them, yeah. There's
one of them.
Yeah.
Okay, no, that's really cool. That's really cool. If you guys have used SciPy, then a Python package for machine learning in general and data science, you guys know what that is. It's pretty cool. Nathan Chang, I'll go ahead and hand it over to you. Thank you, Brendan.
Thanks, Eduardo. Thanks for having me, guys. It's really pretty honoring to sit with all these different guys. And then, here's a company that basically invented SciPy. So that's something that we actually use. So very sorry that we're just learning about the history of it. But I guess before I get into answering the questions, and I'm sorry that I don't have any visuals, but when we talk about digitalization in the energy industry, I think, back in 2012, when I first joined Fugger, that was literally the first time I actually jumped into an upstream oil and gas engineering company. Before that, I was in energy trading and everything downstream. And digitalization was just kind of like a very quiet whisper here and there. And I was in the IT group, and then ultimately I ended up leading R&D and innovation before I left. I think that every executive in every energy company knows that digitalization is really where they have to invest. There isn't an oil and gas company, except for maybe Saudi Aramco, that isn't investing in cloud. So I think digitalization is really where energy is going. And the energy transition, I think, is the other piece that we really haven't really talked about yet. And when you look at the strategy of these large companies, they are pushing to transition into more sustainable, into more renewable energy. And that's being driven by digitalization. Digitalization, I think, in the realm of new technologies and in new industries is just so much easier to apply than in these older workflows and in basically the dirty oil field. And that's hard because I think everybody on this call will agree that energy independence and energy security is the main driver for economic growth. It is like the bedrock for it. And if we want the world to become, sorry to say we're American, but more democratic, more free, and more prosperous, we have to make sure that energy becomes cheaper and more accessible and more secure. And I think that is the crux of it all. That is the aim. That is what we're trying to achieve with sustainability at the end. So moving on, when you take a look at a company like Quantico, and by the way, guys, I think you already know that all we do is data science. All we do is machine learning and software. We're a 10-person company, and at the heart of what we do is sustainability. At the end of the day, the founders of the company came together with a mission, and I think that mission had sustainability at its heart, and sustainability continues to be at the heart of what we do. The mission was, hey, let's log wells using machine learning and AI, and let's not have to deploy any human resources, and let's not have to deploy any assets. And in the world of ESG, that means one, we're non-destructive, and we don't actually risk the environment with nuclear sources at all. Anybody that actually knows anything about like how density data is acquired, that there are some really harmful sources that they send out there. And anytime they lose a source downhole, like say for instance offshore, everybody knows what red cementing is. It's bad. And at the end of the day, our technology, which has actually been qualified across the entire industry, it means that less nuclear sources are getting out there and less people are being put in harm's way. And ultimately, the price of logging wells is dramatically declined by 75% anytime our technology is actually applied. So at the end of the day, sure, that's a small piece of the pie in a $2 billion oil field, but that's really how we're gonna, take care of the elephant one bite at a time. So moving on, you take a look at what else Quantico is doing. We're starting to get into drilling optimization, helping companies better understand real-time risk and how to increase drilling speeds and lower drilling times and lower the cost of developing a field. The other thing that we're doing is actually real-time earth modeling, and all of this is to basically lower the cost of pulling oil out of the ground, finding oil. For the most part, I think that what we do, it's every day we go to work thinking about how can we lower cycle times, how can we lower the resource burden, and ultimately how can we lower the impact on the environment with the technology that we have in our hands that we can bring to bear. So that's the answer to question number one. Question number two, what is your take on the impact of machine learning and data science in our industry? Arvind touched on it. He basically he used the title of a very popular Netflix movie right now. If anybody watches Netflix, The Old Guard, but it is tough because there are 50 to 60 years of process and science that's gone into how to develop an oil field, how to look for oil, right? How to mitigate geohazards, and at the end of the day, I think even though the world believes that oil companies are greedy and dirty and don't care about the environment, trust me, there's a lot of time and sweat and blood and tears that go into making sure that we do our best by the environment. And we're having to work with these groups that have very real, strongly risk-averse workflows and process in place that are scientifically grounded. But the truth is that, science only gets us so far, and machines and technology are starting to really catch up. And I mean, for us, the challenge really is just about, hey, how do we convince them? It's not about selling anymore. It's about how do we, convince these scientific teams and these communities to see that results are coming from, the application of this technology. And it's not that it's beating out their scientific results, but it is highly enhancing the capabilities that they have in their hands. And so for us, that's the real challenge. And we continue to fight that battle every day. Not that we're going to war, but yeah, it's our main goal every single day of our lives, is to basically teach the oil industry about the technology that they have and how it can really, really make an impact, not just on their bottom lines, but on the betterment of the world. So let's see, I think that pretty much covers my answer to all the questions. I look forward to the rest. Thanks, guys.
Awesome. Nathan, thank you so much. Obviously, we talk every day, and you emphasize all those points about sustainability and what Quantico is helping bring to the market. So thank you so much for sharing that with everybody. Everybody, we're going to transition now into our, what I'm calling brass tacks Q&A. Basically, we have some curated questions that we're going to throw at our speakers. We're going to challenge them on some key topics right now in our industry regarding data science and machine learning, and we're going to see how they fare. Liz, I'm going to go ahead and start with you, and then what we'll do is if you don't want to participate in the question, just wave it off. There's no big deal. No feelings hurt. There's plenty of content here and plenty of knowledge that you guys have already shared. So this is just a bit of a challenge here, right? So first here is what stages of oil and gas production cycle are missing data literacy or slow to adapt data science? And how critical is data literacy to members outside of research and development? So basically, if we're talking about business units or engineers day to day, why is data literacy important to them?
I mean, this is actually a perfect question, since I just started teeing it up with data is job zero. I think data literacy is absolutely crucial. I think that it's really easy to put together like a big picture thing you want to get done, to work backwards, have this ideal end goal in mind. But when the rubber meets the road and it actually comes time to that implementation, successful digital transformation, and even by that, I mean successful project execution, is so much more about the cultural elements than about the technology. You've seen so many innovative technologies presented here today. There's so much we could actually talk about in terms of how we can really fundamentally change how we're doing. But in order to get there, data literacy is that enabling point that gets you to scale up. One example that springs to mind is the example of a shared lexicon. I like to call it Rosetta, or the notion that as a data engineer or data scientist, the words I use to describe things are likely going to be very different than what as a geologist I would use, or what as a field tactician I would use. If I'm working wellheads and separators in the field, the words I use to describe where the data goes, how it fits in, they might be very different. You might be able to grok what the end goal is there, but that misalignment and not having that shared lexicon, I think, is foundational to data literacy. One technique that I want to share, and I don't mean just to point out that data literacy is a huge problem, you should solve it right away, because it's not an easy problem to solve. There's a few techniques, though, that I think can help with the cultural change. Things like empowering every single person to ask, what is this? What does this mean? And then to take it a step further and be willing to explain that. I could go into the weeds right now talking about the potential role of CNNs on first pass seismic interpretation, and we could really go into depth about how we could use technology to solve problems. But for the vast majority of use cases, that's just going to cause your audience to disconnect and not start to build those data literacy competencies. So creating an environment where people feel comfortable to ask questions, also empowering people to own their data literacy. If they don't know what that word means, if they don't know why people are talking about SQL or Postgres or what Matplotlib or SciPy is, like, encourage your team to ask that and celebrate that you are asking that, and create a culture where you can start to use that rising tide to raise all ships.
Excellent. 1 point for Liz. Awesome. Great, great answer. I mean, I'm going to go through the roll here. If you want to wave it off, just wave it off. Josh, I think you were next in the roll, the way we came into this. So do you have any comments on that?
No, not in particular.
Hey, no problem. No problem. So I think next we had, I think it was Claudia.
Yeah, I do want to comment on data literacy. I mean, this really goes across everything we do today. Whether you're geoscientists and you actually have to deal with the type of data that most of you probably deal with, business units, marketing, but then also as a citizen, I think everybody has to have data literacy. Just looking today in COVID-19, we're flooded with data and most people can't interpret the data. So they really have to take whatever journalists interpret. And I can tell you a lot of that is just plain wrong too. And so learning how to ask the right questions with data without necessarily knowing how to analyze the data using Python or any of the other tools, but the outcome of a data analysis, being able to interpret this and critically analyze this, I think that's something we're certainly on the academic side, we've been trying to teach data literacy now for quite some time. We can do a better job, no doubt about that, but I think it's absolutely essential to be a citizen today.
Excellent. Thank you so much, Claudia. Point for Claudia. Awesome. So I think next was Arvin. Arvin, do you have any comments on that?
Yeah, I'll actually pile on Claudia's comment that does everyone need to learn Python and able to actually start their Jupyter notebook and solve some problem? I don't think so. And when I hear the data literacy term, I actually, in my head, I actually decompose into two parts. One is actually able to interact with data in a intense way versus able to understand the flow of data. And I actually differentiate between those two, that understanding the flow of data, importance of data is actually more important than having the ability to interact with it in Python or Rust or whatever you choose your favorite tool. It's the mapping the data flow in and out of it at an organizational level is kind of key, and I'm branding it like data literacy as mapping data flow.
Okay, thank you, Arvin. Point for Arvin. Thank you so much for sharing. Who did we have next? I think it was Brendan. Do you have any comments on that, or do you want to pass for the next question?
No, I mean, I think I'll add a comment. Those are all great points, and I agree with them. You know, from working hand in hand with domain scientists using these tools, I have found that, you know, we have years of experience. They have years of experience using data to make business decisions. Okay, now we have some extra tools and techniques that are new, and new ways of using and integrating and leveraging these large data sets together. But I mean, if we had tools that actually integrated that data and presented those domain scientists with, you know, visualizations and data in the form that they were used to making decisions with, you know, that would streamline the process. So, you know, in order to make effective business decisions, like Arvin was saying, everyone doesn't need to be a Python coder, right? So that's not the literacy that's important. You know, and that being said, the data scientists also have to know what it is that that the domain scientists need in order to make better decisions. So I think there's sort of literacy in both directions that's important to make better tools and software that can streamline these processes.
Excellent. So thank you, Brendan. Thank you for sharing. Another point for Brendan. Nathan, you have a comment on that, or should we move on to the next question?
Yeah, I got a short one. I'm with Claudia and the rest of the guys here. Like, data literacy is incredibly important outside of R&D. You know, R&D is basically driven by contextual need and value from the business outside of R&D, right? Organizationally speaking, like, you know, their understanding of data and how it relates to, you know, business problems or value proposition or value drivers in a business, That's literally how we define scope. So, you know, they need to understand their data. They need to understand where there are gaps in their data. They need to understand how it's interpreted internally and externally. And you know, there's loads of different use cases we go through. Like, I mean, I can't remember, I think SourceWater was showing like satellite imagery of, you know, construction on an oil field. I mean, I literally had like Shell in my office one time, Shell CapEx Base saying, hey, you guys fly drones and take LiDAR. Can you tell me how quickly my buildings are coming out of the ground if I tell you where the sites are? And of course, our question is like, well, what, why? And he's like, well, because, you know, I have to manage this giant, you know, multi-billion-dollar project, but our biggest problem is when certain buildings come out of the ground faster than planned, then suddenly that creates a dependency problem with other nearby infrastructure. You know, the list can go on. One time we had like an offshore platform basically asking if we could do corrosion classification and identification from high-res 3D imagery from drones. You know, I mean, I think at the end of the day, you know, these are people that are recognizing like, you know, innovative ways to address their problems, right? They have a strong interest in technology, which is the same thing as practically having a strong interest in data. And I think it's people like like everybody on this call that are going to be able to, through their data literacy outside, if you're in R&D, that's what you want. So I think it's a phenomenal and very important thing. Yeah.
Excellent. So just for everybody in the audience, I mean, we talked about some key points there. I mean, I think it really comes down to kind of what Liz said, like an organizational responsibility to make sure that across the board, people feel comfortable with learning about data science and just data literacy in general, as well as like Arvind said, decoupling it from like the coding side of things, and like Claudia said as well, right? You know, it's broken down, and there's evidence throughout the industry and other verticals where this is important. So thank you guys for sharing. Wonderful. So now I'm going to jump down and start with Josh this time. So the oil and gas industry is full of decisions that are made potentially over the course of months and years. Lots of levels of decision-making, lots of bureaucracy. In that kind of technology model, how valuable is real-time data? And are companies getting the most out of it? Do we need to have significant infrastructural changes to make sure that like a real valuable return on investment is evident from real-time data analytics? So,
well, in the areas that we've mostly been dealing with in basically upstream development, you know, site work, pre-drilling, drilling, completions, and then production, particularly in the water space, it's not even an issue of real-time data. The data doesn't even exist. And so the idea of using data is itself something that we've been, you know, working for 7 years now on just getting the folks in these functional areas of upstream to consider. And when I know that might sound silly, but the reality is, for example, on the water management side, I'll just give you, you know, typical kind of example. The way that the decision about whether a given tank of produced water should be picked up and have a load delivered to a disposal, and when and which disposal, is basically made based on a pumper who's got certain rounds that they're responsible for, and a pumper is basically a maintenance person in the oil field who's responsible for checking on many well sites per day and making sure that everything's working, nothing's leaking, nothing's broken. And one of the things they'll do is check to see how full is the tank. And if it seems pretty full that day, they'll take their phone and call a friend who owns a trucking company and ask their friend to send a truck to pick up that water. And 4 months later, an invoice from that trucking company will get paid by somebody in accounting who has no idea if the water was really picked up, how much was picked up, where it was taken, how much water was actually in the truck, or why that particular truck was called. It's not based on who has the closest truck at that moment. It's not based on who has negotiated the lowest rate with the operator. It's not based on which disposal has the most capacity or lowest rate at that time. It's just based on who had the best relationship with that pumper, who was also on the approved vendor list that might include 100 different hauling companies for that particular operator at that moment in time. And so there's not even when we talk about real-time data, you can imagine an Uber for the oil field situation. That's kind of the buzzword, right? Out of the 10,000 water trucks driving around the Permian Basin right at this instant, which is the closest empty truck that's offering the best rate, and to which of the 8,000 commercial disposals in the Permian will it take that load of water based on the combination of closest driving distance, lowest current spot rate, and shortest waiting time at the disposal, right? That optimization could, in theory, happen every time across the 1,500 hauling companies, 8,000 producing operators, and approximately 8,000 commercial disposals. But today, there's not even the beginnings of that. It's still a guy calling his friend and saying, send the truck and, you'll buy me a beer later because I've just made you $100. So that's that's kind of the point that we're going from here.
Well, thank you so much, Josh. And by the way, guys, this is in the audience. This is exactly why I really wanted Josh on this panel, as well as it's a completely different perspective, right, than just strictly geoscience. There's just so many applications for this stuff across the industry.
There's a lot of science happening. I'll say, there's a lot of science happening under the ground. There's a lot less science happening on the ground.
Right. Yeah. Exactly, Josh. Thank you so much. Arvind, I think you were next on the roll. Do you want to wave this one off? You want to comment on the real-time aspect of things here?
I'll make a comment. And again, I'll add dimensionality to this, is that real-time versus on-demand. So when you talked about this decision-making cycle, the decision maker don't need actually constant real-time information thrown at them. But what they need is that when the critical junction happens, the information is available on demand. So there's a small distinction, subtle, but small distinction, that real time is really good for predictive maintenance and all those aspects of it, where you are actually measuring things on real time and decision is happening on the fly. A good portion of subsurface decision are happening in terms of risk and uncertainty and volume and all those things. Whether you want to make that $100 million decision to drill a well there on that prospect, or $1 billion purchase of a certain acreage in Brazil. So I don't think people are going to make a real-time decision on that. We are not there yet, and it will be a while before we'll get there. What they need is on-demand results. Is that they don't have to wait for 6 months to get information to them when they actually need it. And that's the kind of, we have to rethink a little bit, and infrastructure changes will be needed. And there are two other items related to that, is cognitive load and cognitive ease. So cognitive load is that when you have a lot of information, is if I want to actually make a, let's say, density map of an area, from a lot of well logs, if I have to actually go and physically do it with the clunky toolkit available to me today, it actually start to put cognitive load on my head. And I will actually go the path of cognitive ease, that I'll actually take whatever easy and available to me and make my decision with that. So how can we actually reduce that? And that's actually making our tools easy to use and on demand. So that's 2 cents on that.
Thank you, Arvind. I appreciate it. Great points there. Brendan, do you have any comments there?
Yeah, so just real quick, I guess we built tools that kind of are at both scales, right? There's different kinds of decisions we need to make in oil and gas. On the operational side, And for certain like HSE considerations, we're leveraging a lot more real-time data, and there is infrastructure to handle some of that. SCADA systems and controllers have been around for a long time. I think more recently we've been applying machine learning techniques, recurrent neural networks and so on top of those for failure prediction and so on. And so some of that's there. I think that infrastructurally that could benefit from more technology to integrate data from different sources. So one challenging project we were on was kind of a real-time dashboard for monitoring a complete hydraulic fracturing job from, the pump trucks that were out there were streaming out real-time pressure data. We had 2 different microseismic monitoring companies that were streaming out data, and we were trying to tie all that together. And there wasn't great ways to actually manage all of that, sync up the time and so on. So I think that there's something to be given there. Yeah, and I think I mentioned HSE, but I think that's a big area that could benefit from more real-time decision making. Many of those long-term decisions are going to need to be long-term for a while because they involve large capital expenditures, which means that they need to be de-risked over a long period of time to, evaluate that. Yeah.
Thank you, Brendan. I appreciate it. Claudia, I noticed I jumped straight to Arvin. Claudia, do you have any comments on the real-time aspect? Claudia, I think I lost your audio there. We'll go ahead and then jump to Nathan while you troubleshoot, okay? Nathan, any comments on the real-time aspect there, that question?
Yeah, I mean, just a couple of small ones. I mean, definitely, I like the comments from SourceWater on the on data and how unstandardized it is and how really filthy it is in the oil field, and what it's like to deal with that and try to solve problems in a data poor environment. But no, I think real time and how to use real time in decision making is evolving. These are 50-year investments, right? That oil companies are making, and they're very slow and methodical for very good reason. And for them to suddenly start thinking about how to shift their entire process and how they make decisions to utilize real time data, it's just going to take time. But I can tell you that we've definitely been able to bring about a return on investment in real time, just this year for oil companies. I mean, Liz knows about it. She contributed to the paper, and that'll be coming out soon. But there was an oil company that was actually drilling offshore, and they took our real time logging solution out there, and in real time, they got stuck pipe. So if they actually had sources downhole, they would have lost those sources. Luckily, they didn't have to deal with the sources. They were able to get unstuck in a couple of days. But in real time, they were able to see that one of the data channels that was being used by the machine algorithm was suffering from degradation or maybe some miscalibration, and they had to switch in real time and got the data that they needed in the accuracy. And subsequently, they were able to update their economic model because they hit an early payload that was unexpected and not identified in the seismic. And subsequently, they were able to basically hit bedrock faster after the main TD so that they could set their casing without having to drill an extra day. I mean, I think real time has phenomenal value for the oil and gas companies. It's just going to take time, which is a bit, indirect.
Liz, do you have it? Thank you, Nathan. Liz, do you have any comments on that real-time aspect?
I do. My general ethos in life is like data is good, more data is better, just because in general, more data is better. I do want to point out the caveat that I think strings together a lot of these comments, and that's real-time data and time series data is a very unique animal. A lot of the same anomaly detections that you would use for non-real-time data or even non-time series data and the assumptions you can make. Is it normally distributed? Is it log normally distributed? How can you move from descriptive statistics to something that's more impactful? I think those are a unique challenge in time series data, and that is really what one of the key value adds that everyone has spoke about is taking that unique data source and not being able to just look back, but use it for perspective. Plus, the algorithms for time series data are just cool.
Thank you so much, Liz. So we're getting right up against the clock here. I have one more question for all the panelists, and it's a little bit different, and we'll do a super lightning round to get I want to get everybody's perspective here on this. If you had one client, one individual within your company, a stakeholder that is on the fence about adopting a data science driven workflow or machine learning driven workflow, what would be the one thing you would want to share with them today? So I'll start off with Claudia. Did we figure out the audio issue? Oh, there we go. Yes.
Okay. I don't know what happened. I was unmuted. Anyway, I mean, I would probably talk to the person about a specific problem they have and try to do a pilot project with them to try to convince them of the value of it, and really sort of take the customer perspective. What do you expect from it, and could we deliver on this? And we may or may not be able to deliver on it. So sometimes skepticism is also a good thing.
Excellent. Thank you, Claudia. Arvind, you're up next.
So we face this challenge more or less every day because we have products and we go to our clients, and at the heart of it, most of our client likes us because we do good science, because they are actually scientists. They are we have to respect their skills, and some will take longer, some will take shorter, but if you are fundamentally good science, doing fundamentally good science, then you will prevail. And I add to that, sit down with them and understand what is their problem and what is their concern. The concern may not be what we are thinking. Like, for example, our ARLAS is our well prediction product. And the concern was actually less about the quality of prediction. It's more about the usability of it. And hence, we actually solve that problem by listening to our clients. So whether it is internal or external, sit down and map out what their concern is, how they're doing today, and how you envision it doing in future. And then you will be able to solve that very easily.
Thank you, Arvind. Thank you very much. All right, Brendan, you're up.
Yep. So I completely agree with what Arvind said. Our customers are always scientists as well, who are used to making conclusions based on evidence, right? And so, so we have to demonstrate repeatable, reliable solutions that really solve the business problems that they're tackling. And that tends to win over any audience.
Excellent.
In our experience. Yep.
Thank you very much, Brendan. Nathan, you're up.
All right. Yeah, I'm definitely with the approach that Claudia brought out. We fund POCs for our clients. We definitely put our money where our mouth is, or where our product is. And at the end of the day, that is always won our clients over. Let us just show you what it will do. Let us compare results. Let us qualify the data science against the science. And I think that has always been incredibly successful. Yeah.
Excellent. Liz, you're up.
I think it's actually been said so eloquently from everyone else. Show, don't tell. Go build something, get an MVP or MLP, minimum lovable product, get it out there, show the possibilities, think really big, and snowball up to gain traction.
Excellent. Thank you, Liz. And Josh, last but not least.
Well, SourceWater offers a market intelligence platform. And so the purpose of the platform is to show what everyone else is doing, not what you're doing. Though we often find that we show people what they're doing and it's different from what they thought. And so what we're really up against is that we have to scale a few levels of intelligence gathering to get to where the kind of real-time machine learning based insights that we're working on become applicable because the first level of market intelligence, and the one that still prevails throughout the industry, is I know a guy told me this, my buddy told me this, everybody knows that, you know.
Right.
And we saw it early on when you would talk to people and say, what's the price of water? And people say, everybody knows it's 50 cents a barrel, except that we were talking to people saying, oh, I'm getting 2 cents a barrel, and other people saying, oh, I'm getting $3 a barrel. And these people might be next door neighbors for the same water. So clearly something's going on where what everybody knows isn't actually what's happening. And then you step up from the, I know a guy, I trust him, I've known him for 20 years, but actually he's telling you stuff that he's not saying to the other people, or he's saying something different to different people. And there's lots of guys out there. And then you get to the level of, okay, let's use data, but what people use is the regulatory data, which is often inaccurate, usually out of date, often erroneous, because it's filled out by the same people on the ground and it's never checked and never enforced. And so it can be 3, 6, 12, 15 months out of date, or just missing or wrong. And so how do you check that? Because the more advanced people are using the regulatory data to understand what's happening, but they're looking way in the past and the data is super inaccurate. Everyone knows it's inaccurate, but it's kind of like a mentality of, well, everybody's using the same inaccurate, missing late data, so we're kind of all in the same boat. And so what we're bringing forward is something that is close to real time. We actually are doing some real time intelligence now because we track over 20,000 oilfield workers who use our mobile phone app. And so we're able to say, here's where the activity is happening. Here's, you know, where the supply chain relationships are changing. These wells have been shut in. These wells have been reopened. And that's where we're moving toward. But for us, it's really a cultural and educational challenge to say, you know, you're 1 or 2 people who you rely on for information are not the only sources out there, and sometimes are not correct, and they don't want to hear that from us. Or the data you're getting from the regulators at the end of the day actually comes from those same people with the same kinds of inaccuracies and delays. And so you need third-party sources, and we need to validate that. So it's, you know, we've been at it for 7 years, and it is a little bit of a challenge, but people are starting to come around on these things, and we try to just keep showing results.
Excellent, excellent. Well, thank all of you for participating today. I hope that everybody in the audience sees that we have an immense amount of talent and initiatives, entrepreneurs and thought leaders in our industry that are going to get us through these tough times. The ideas are there, the technology is there. It's just about us working together to really make that impact across our industry, make sure that not only do we survive today, but we thrive into the future with sustainability, both economically, environmentally, and socially across the board.